We are now going to review solving systems of equations by elimination. Elimination is exactly what it sounds like. You want to eliminate one of the variables. So when we look at this system of equations, you're going to want to pick which variable would be easier to eliminate. And the one that's easier to eliminate is the one that has coefficients that can easily become the same number. So for x, I would figure out the 3 and 5. For y, it's 4 and 1. That's going to be easier to get to be the same number. So that's where I want to eliminate the y's. I want them to be the same coefficient with a different sign. That's going to make them cancel, which is eliminated out of the equation. I can get these to both be the same coefficient by multiplying this second equation. And I want to multiply it times a -4. That's going to give me a -4 coefficient here, and then they would cancel if I added them together. When I do that, I can't change the equation, so I need to multiply that -4 times everything in there. So I do -4 times 5x, which is -20x, -4 times y, which is -4y, and don't forget -4 times 30 as well, so that gives us a -120. You've got to multiply the entire equation so that you are not changing it. The other equation is just going to come over so that they're lined up. Now I've got my x's lined up, my y's lined up, and my constants lined up. I am going to add these two equations together. 3x and -20x give me a -17x. 4y and -4y give me a 0. Those cancel each other out. And then 52 and -120 give me a -68. I have eliminated the y variable, so now it's just a one variable equation. To finish solving, I divide by -17, and I do that to both sides. X is 4. Now, I'm not finished. Just like with substitution, you would want to take that and plug it back in so that you can find its corresponding variable. So you can plug it back into either one of the equations. I'm going to go ahead and pick the second one. So I get 5 times 4, which is my x, plus y is equal to 30. Now I solve. That's 20 plus y is equal to 30. I subtract the 20 to get it to the other side. Since it's positive, you'll always do the opposite when you go into the other side of the equal sign. That gives us y is equal to 10. And so my ordered pair would be 4, 10. I've solved that system using elimination. We'll go ahead and practice another one now. So we've got 2x minus 5y equals 6 and 4x plus 3y equals -1. I look at these and they all have coefficients. I still need to think about what's going to be the easiest to cancel. In this situation, x is going to be easier. It's easier to get 2 and 4 to be the same number. They can both be 4. So I'm going to multiply this top one times a -2 because I know that's going to give me a -4 here, which will then cancel with that one. So I multiply my entire equation. -2 times 2x gives me a -4x. -2 times -5y gives me a positive 10y. And -2 times 6 gives me a -12. Don't forget to do that last term. That's the one that students always miss because they forget to distribute that all the way to the end. Now my other equation is just going to come over so I can have it all lined up. So I get 4x plus 3y equals -1 right below it. And it's time to add those two equations together. -4x plus 4x is 0. That's going to cancel out. 10y plus 3y gives us a 13y. And -12 minus 1 gives me a -13. I divide by 13 to get it to the y by itself, and I get y is equal to -1. Again, we're not done there. You never want to stop there because you're only going to get 50% of the grade on that. You want to plug it back in so you can find its corresponding x value. So I'm going to plug that in for the first equation, and I get 2x minus 5 times a -1, because that's my y value, is equal to 6. When I multiply -5 and -1 together, I get a positive 5. I subtract the 5 to get it to the other side. That gives me 2x is equal to 1. I divide by 2, x is equal to 1/2. And so my ordered pair is 1/2 and -1. All right, we've got one more example for you here. On this one, it's not as easy to get a common coefficient here. We're going to need to work a little bit harder. So I look at it, and this has a coefficient of 2, and this one's got a coefficient of -5, and then we've got a coefficient of -9 and 8. So I want to figure out which one is going to be the easiest to cancel. In this case, the 2 and the 5 are probably going to be the easiest to get to be the same. I'm just going to have to multiply both equations instead of one to get a common coefficient. So the top equation, I will multiply that times 5. The bottom equation, I will multiply times 2. That is going to make this top one 10 and this bottom one -10, which will cancel out when we add it. Now remember, you have to distribute that to the entire equation. So when I distribute the 5 here, I get 10x. When I distribute the 5 to the -9y, I get -45y. And 5 times 8 gives me 40. Now I distribute the 2 to that whole thing, and I get -10x plus 16y is equal to -40. Now we're ready to add. 10x and -10x is 0. That cancels out. -45y and 16y give me a -29y. And 40 and -40 is 0. Now we've got -29 times y equals 0, so I'm going to divide by -29, and that is 0. Of course, we're not done there. We have to take that and plug it back into one of the equations to find its corresponding x value. So I'm going to plug that in, and I get 2x minus 9 times 0 equals 8. -9 times 0 is just 0, so that goes away. We get 2x is equal to 8. We divide by 2. X is 4. So our ordered pair is 4, 0.